I have a second speaker thing up that I am closing from the WebEx, so I don't hear you guys, but I may be asking you guys some questions throughout, and I'll hold the mic near the speaker. But I just want to have the ability to turn you guys on and off without having to fitz around with the programs. So, without further ado, let's get this started. So the way it's going to be working out is we have a set of scenarios that are not the whole list of things that we evaluated you guys over. So this is the whole portfolio that we ran evaluations over and collected data, and we have a web application link that will link to you guys after the competition. But for what we're showing you right now, we'll be showing an abbreviated version of that portfolio. So what's going to start off with is we're going to see a number of tests to see how you respond to asteroids coming at you and asteroids next to you but not coming at you, to see if you can evaluate threats. We've got a single small asteroid test for accuracy to see if you can hit a small fast-moving target. We've got a simple slow-moving wall from different starting points coming at you. We've got different circle-shaped rings that are doing different things. We've got static versions and one that is closing in on you. Then we've got more wall scenarios where they wrap at you from different angles. So our goal with this was to try to test certain edge cases in your controller to see if you have produced something that can handle more than just a couple asteroids around you. Can you handle something that is more of a threat than another? Can you hit a single asteroid moving quickly? How do you respond to the map wrapping? How do you respond to being enclosed by asteroids with no way out, except for a tiny hole specified by if it's on the left side, right side, top, and bottom? So we'll be walking through these scenarios on a team-by-team basis. So we will first start off with Sam King. Sorry, I didn't know your team name was actually Harry Stamper's crew, and it's just going to show up as Sam King for now. But without further ado, let's start running through the show portfolio for Sam King. Okay, right in the beginning it seems like we are favoring shooting up top. There must be some scary aliens there we can't see. One asteroid closing in. And oh, almost got out of the way there. Now we're starting to aim right.
Hey guys, I cannot join the YouTube, I don't know why. Hey.
Okay, it looks like we're getting some shooting when we don't need to shoot, but we are hitting some asteroids with this sweeping shooting motion. Accuracy is suffering because of this. And then now we're stuck trying to chase that asteroid that did wrap, and then we adjusted to another asteroid. Oh, and we're not leading the asteroid, we're shooting where it was. See that right there? Okay, good start so far. We're starting to get some breaking apart, but not in any tough situations yet. We got that little guy come in. A little avoidance there, we see. The choices of shooting some further away asteroids are interesting, because perhaps maybe we want to be shooting something closer because those might be a bigger threat. But the ones coming close aren't coming close quickly, so they are not that big of a threat. Okay, now we're getting some wrapping situation. We avoided it for a second, but then backed up back into that smaller asteroid. Oh, moving forward to that individual asteroid was interesting as well. Backing up into that one. Wow, we need a backup assist cam on this spaceship. Okay, so this is the accuracy test. We're trying to see how good we are at shooting a moving target. And it seems from what we're seeing right here is what we saw earlier, where we are perhaps shooting where the asteroid was when we shot, as opposed to leading the asteroid to where we'll be when the bullet will get there. And this might be going on a little bit, unless we get lucky.
Yeah, it seems in these situations that, sometimes it's good to be conservative and try not to move. But maybe in this case, moving closer would help with that lead problem.
Yeah. Especially if you're not calculating for lead, definitely being closer to the asteroid will make you more accurate. Ooh, that one was really close right there. We almost got it on the snapback. Oh, so in this case, we are shooting during that sweep back up to the top, which is interesting because I don't think we saw that on the other side. Oh, and we got it because of that sweep firing motion. See, we're seeing some of the sweep action again, and ooh, getting some interesting wrapping right now. Are we able to hit this with these interesting angles it's coming in at? Because before, it was just coming in on one side of the screen and going vertically or horizontally. This one, we're not seeing firing on that sweep, but we were seeing it on the other side. Alright, here we see the sweeping action is now starting to create a big problem. We now have a ton of asteroids that we have to worry about. We can start to see the simulation environment slowing down as well. Sam King did mention this in his presentation. This may be happening if his controller is processing slower than the simulation time, in which case it slows everything down because the environment is synchronous and not asynchronous. So we see that type of sweeping firing may be good for getting an immediate score boost, but is not good in terms of long-term strategy because you are now creating a lot more of a dangerous environment to operate within.
And as the one team mentioned, they discovered the game in the game of keeping the asteroid count down, which may also help with the processing situation.
Oh, we got this guy coming in, and we did not see him. Looks like we need to install some backup cams on this ship. Looks like this is becoming an issue. So far, so good. Nothing coming in from the side, but a narrow miss on the left side. That was a close one. Oh, we're starting to see some backup, and we backed up into that little asteroid. This wall was eliminated at the start, right down the middle, and this opened up some immediate safety for the ship. But again, we've created a situation we don't want to be in, surrounded by asteroids and nowhere to go. Kind of stuck right now. It doesn't seem like we are trying to move to avoid any asteroids. But okay, seeing the same sweeping mechanic, but we got locked in on that second from the left, or third from the left. Oh, we got some small guys coming close. There could be a death right there. Interesting. Firing into space, maybe trying to be proactive about future asteroids. And this is the situation we all want to see. The apocalypse scenario. The ring closing on you. What are you to do but with your back against the wall, fire at anything? And it's closing in. We don't have much more time. Oh, he died. Okay. Seeing this ring, it's really interesting. We're shooting instead of maybe leaving, so perhaps it's good to incorporate some type of behavior system to check if you have a way out, or maybe you shouldn't be firing in certain situations. But in this case, it's not so dangerous right now. We might actually be leaving the circle now. Now thinking about it, checking to see if the temperature's alright. Do we need a coat? Do we need a hat? Okay, oh, don't back up into that. Seems like we really like our backing here. Must be warm in this little pocket. Oh, a little too warm right there. Yeah, and something like this, it's probably worth it to get away from the circle. You know, where this strategy might have worked in different scenarios, where staying in one spot just allows you to carve out your own little safe space. Now, it won't help because this is a dangerous place to be in. You shoot one wrong bullet and then it starts crashing around you. Oh, last one, got him right there. So this is the wrapping scenario. We are checking to see how we handle recognition of targets which are wrapping from one side of the map to the other. See, we see that behavior mostly in the beginning, right here where the wrap happens, and then it sort of devolves into a normal scenario where a lot of asteroids flying around if you're not managing your targets right. So what we would like to see would be some interesting behavior where you recognize the wrap is happening, give yourself an exit plan, and get out of there. And then maybe carve out some channel for you to work within. Because we will always have to contend with these sideway motions until we break them, and then the smaller asteroids go on a pseudo-random path after that. Oh, interesting. No recognition right there. Not even shooting. So I will also add to you guys that are listening right now, we have some situations where some code may crash, and what happens in the environment is if your code crashes, we will catch that exception, ignore it, and move on. But there may be circumstances where your controller does crash. I don't think we see it that much, but it does happen sometimes, and some of it's divide by zero errors, or some other small things like that. But okay, we have this little channel carving out. This is a good start, but how do we handle the rest of the scenario? Uh-oh, we're going back into the danger zone. We got an asteroid coming right near it, and got hit by that one. Okay, it looks like our accuracy is dropping shot by shot. We're hoping we'll get an asteroid. And there we go, we're back in business. Getting some danger on the left side. Couldn't pull that one out.
Yeah, so it is interesting balancing the offensive capabilities for increasing your score with, you know, maybe path planning, or maybe not explicitly path planning, but trying to find a better place for you to go before shooting a lot of things.
Yeah, thank you for that, Tim. Good point. Sometimes the battle becomes when you're developing AIs like this to try to think of scenarios that your code doesn't account for. Whereas you as a human might already think implicitly about certain edge cases, the computer doesn't know that, and you have to do that for the computer and come up with that in your controller. Looks like we are seeing some slowing down like what we did before. This can be expected sometimes if you aren't proactive with maintaining the number of asteroids to a low level, and then your algorithm is processing actions over all the asteroids. If your algorithm takes X long to run and you're running it on some data that's 10 times longer, then of course we'll see some type of slowdown. So this slowdown in your algorithm could be a very big point of improvement, especially if you had slow training times. Because with genetic algorithms, since you are throwing a lot of darts at the wall, so to speak, if those darts take a long time to get to the wall, then you're going to be taking a long time to train. So it helps a lot to make sure that your algorithms are computationally efficient.
And Sam did just mention he tried adding in some path planning, but had issues with the response of the ship. And yeah, there are lots of issues that you'll run into sometimes when you have good strategies that you want to implement, but they don't go the way you expected.
Okay, so what I'm going to do right now is I'm going to switch the audio back so that we can hear what Sam has to say about his controller. So on the WebEx, Sam, if you could unmute yourself, if not, seems like he's not there. So we could give him a second to come back on and just get his thoughts on what he saw, if it was what he expected, and we can see what he might be thinking moving forward. Okay, cool. We just got a message from Lynn that says he is on his way. Lynn, Javier, do you have any comments about what you saw during the videos that you'd like to talk about?
Great commentary so far, Brandon. I think we have Sam back in the WebEx now.
Good, awesome. Sam, I'm sure you saw the YouTube video, saw some of your comments. What are your thoughts on what you just saw?
Yeah, it really pretty much responded like I expected it to, because, well, for two reasons. One, I only had a collision avoidance system in there, so there was no like long-term path planning or any goal position that I was trying to get to. I never really got that far in the programming of it. That was something I was trying to work on, but just sort of ran out of time. And then, yeah, I used the GA to learn the shooting, like what makes it shoot. So I sort of ended up with a shooting membership function that's skewed to the right-hand side of the ship, and that's why you could see it. Yeah, I just noticed in some of the scenarios, the firing situations were a little bit different right to left.
Okay.
But other than that, yeah, it pretty much behaved as I expected. Like I said in the chat, I tried the first thing I did was try to incorporate a path planning where I could just program waypoints, and then my ship would fly around and sort of shoot at stuff that it sees. But yeah, I had problems with I would get to a waypoint, and then I would be trying to get to the next one, and it would take such a big sweeping turn that it would end up going out of frame, and then it would just throw the whole waypoint system sort of out of whack. But that was definitely something I wanted to add, because I think it'd be really beneficial to have, like, okay, I'm going to fly call it like a square pattern, or I'm going to go around the perimeter of the screen. Just that. And then you could also start getting into looking at, like Brandon was saying, like, okay, there's a bunch of asteroids over here, and I'm going to move in a certain direction. Because that's the other thing I did was I wrote an algorithm to generate sort of a heat map of the asteroids, and my goal was to have it move towards the colder sections of the heat map. But like I said, the navigation system didn't really pan out, so that's in the works. The navigation.
Okay, cool. Well, it's good to hear your thoughts on everything. I would like to add, sometimes when we see those fuzzy systems, I think I remember seeing in your presentation where there are gaps.
Well, I'll say that was a lot of work, and Sam, I really appreciate all the work you do. You should be proud of it. That obviously time is the constraint here, and a lot of work for you to put on your shoulders. So bravo for taking this on, for sure.
Oh yeah, thanks. I was laughing. I was like, oh, that team has 3 people. I probably could have tried to find some teammates that might have been helpful, but also the decision making was very smooth because I only had to talk to one person. And that was myself. But,
very true.
But thank you all very much.
Awesome. Well, thank you for that, Sam. Good job. Good to see some good shooting. We saw some really interesting behaviors. Now we're going to take it over to Hey Terry and see what they cooked up for us.
While Brandon's doing that, I did want to point out that the reason we moved this part of the stream to YouTube was because of those frame rate issues that we all saw in WebEx.
Yeah, we want to show this at the smoothest frame rate possible for you guys, so you can see all your hard work, and you can also point it to people at a very easy to access link, which you do have. Right now, the video is unlisted, but if you share that link with anybody that you want, they can see all your hard work. So, without further ado, let's start up Hey Terry's and see what they got going on for us. Okay, interesting behavior. Start off in the beginning, shooting into the top, and then moving out of the path of the asteroid coming in. Backing in a little interestingly there. Seemed to be a good recognition to get out of that path in the beginning. But now we're backing up and shooting away. So I remember when we asked you guys earlier in the week and when you addressed this in your presentation that you did prioritize doing your evasion. So we are seeing some of that behavior where we have a backing away from those asteroids in the beginning. A lot of backing forward. Let's see some turning here. Oh, we're sitting right on that boundary where we snapped back and forth between the top and the bottom. Okay, right here. Interesting. Let's see what he does. Almost looks like he wants to shoot right there at that aiming. There we go. Backing up, backing up. Oh, forward too. Okay, those past two scenarios did not end well. Let's see how we do on the accuracy test. Interesting. This feels like it's a Wild West shootout at high noon. And this is the tumbleweed going by. Locked in. He's getting ready to shoot. We're going to see something. You can feel the tension in the air, can't you?
I can feel it. was also interesting to see the throttle and turn rate responses. It seems like they were switching back and forth pretty quickly. Yeah, so in cases like these, I guess the controller may be a bit conservative in what it's doing, where it doesn't go on the offensive or try to score necessarily, but rather just tries to avoid being hit.
Yeah, so this might be something within how they design their controller. Maybe they aren't built to recognize asteroids that are this close, and they wait until they're closer to address them. We'll see what Hey Terry say on the other side of this after we see its performance over these scenarios. But we did use the Hey Terry 2 controller. We did ask you if we used that one, so this is what we're seeing. It seemed in the code that this didn't quite have the shooting fist that you guys were talking about implementing. And it was just the shoot condition was based off of the velocity. Okay.
Oh, interesting.
Yeah. Shot a little bit there into the distance. Okay, so maybe the cameras on this ship just, they need to go see the eye doctor. Maybe he just has a hard time reading the text at the bottom of the screen. Maybe we'll see a lot better performance once we have some bigger targets. Oh,
yeah,
okay.
very well could be that. Yeah, it just doesn't consider
that a threat.
These asteroids threats. Yeah.
Mm-hmm. Okay, interesting. We're starting off with a lot more Rambo-style shooting in the beginning here. With this throttle, it looks like we were actually aiming. You can see the oscillation back and forth like it was trying to target something. It looks like from the throttle and the turn rate is we're only setting whole numbers. So you can see in the dashboard in the bottom, sometimes we get whole number turn rates, and then we actually, right there, we're getting more of like a floating point calculation. So maybe certain parts of the ranges were calculated by FISs or some other algorithm, just how they separate behavior into different domains of the problem. But okay, backing up, shooting. Let's see what we're doing. Kind of hanging out in this weird gray area right here. Could see some trouble once those asteroids wrap.
It seems to identify the the wrap, but then yeah, definitely I think it's prioritizing scooting away.
Mm-hmm. So yeah, based on what you guys did say, it does seem a little bit more of an evasion style controller.
Looking at the chat, there's also some discussion of if the training was based on staying alive for the longest time, what effect that might have had on all of this.
You know, that's a great point to bring up. The genetic algorithm basically just helps you with what you tell it, so those parameters that you use in your fitness function can make all the difference. That was interesting. We almost tried to exit that circle in the beginning, but we did not. Right here, we're not digging ourselves any holes because we are not shooting at anything, and none of these asteroids are coming in to crash at us. But, you know, we're also not getting a score right now, but maybe he's just doing this big brain move where he's calculating every possibility, you know, like they show in the movies. He's doing math. Or maybe this asteroid ring is like his home and he just doesn't want to leave a window open.
The alien spaceships can't see him as long as he's enclosed in the ring, so it's a safer place. We just don't. We just don't have all the information.
Exactly.
Yeah, to be fair, hasn't died yet.
Yeah.
You know, if I was to pick a spaceship, strategy, I would want to be in the one that doesn't die.
Yeah, that's a good point, Tim. You really hate to see all these spaceships crashing. They should just all live forever.
Interesting that the starting asteroid that's missing has the change of that has also changed the strategy of the ship.
Mm-hmm.
Yeah, I've noticed that. It seems that when asteroids reach a certain part of the state space relative to the spaceship, it only then engages. So there may be some asymmetry in their input space somehow.
Okay. And, yes, from some of the fizzes that we saw during the presentations, there were gaps between the membership functions on the input space, which could, leave some questions open about what is its controller doing exactly in that circumstance. Depends on how you design your fuzzy controller, but you could be setting yourself up to not react in situations where maybe you should be reacting. Okay, let's see the wrap recognition. Actually, almost able to avoid it right there with the respawn timer.
It's definitely getting some good hits in.
Yeah. It's definitely not going down without a fight this time. It looks like this guy just... Maybe he's used to high elo opponents and he just only wants to fight the ones that he feels are a threat. He doesn't want to be playing against silver ones when he's a gold 4.
That's true, and this is just training for next year's Asteroids tournament.
Now, what I'm imagining right now when I hear training for next year's tournament is I'm imagining Rocky running up the steps. How are you going to be Rocky running up the steps with your algorithm next year? So, we're going to take this back to the WebEx and talk to Hey Terry to see what's going on. Is it what they expected? What are their thoughts about moving forward? What would they do differently? So I'm going to switch my audio. So Daniel and... Am I just forgetting Matthew Terry? I don't see Matthew in there.
So I assume people can hear me. Matthew's not in this WebEx anymore. I'm still in contact with him, but explaining the fuzzy system, I'll just get started, I guess.
Okay.
So results, even when we were doing like just simple 3 or 6 or however many asteroids just flying around, we weren't getting great results in terms of dodging sometimes, and so sometimes it literally just ran into, like, it would go the wrong way sometimes, which was unfortunate. In terms of the wrap, we did have a method for finding all of the asteroid positions relative to the ship that only kicked in when we were considering like the invaders to the circle, like that radius 200 circle we were talking about. So if an asteroid gets within 200 distance, then it actually does all the wrapping consideration. And then the shooting, we didn't have like an aiming or anything, so it didn't really shoot anything. And if there wasn't some number of asteroids, it wouldn't shoot.
Okay, interesting. How do you think you would change it moving forward?
We definitely incorporate the shooting into the avoidance. Definitely have some sort of aiming method where it actually seeks out to shoot asteroids. I'm happy with the clustering. We also went back and found out that our first controller, you guys mentioned like High Terry 2, High Terry 3. Our first controller, High Terry 1, actually gave us some better results for the dodging. So we'd like to go back and consider that for the dodging more. And then in terms of shooting, we'd have to put in a lot of work to that.
Yeah, I really like the idea of clustering the asteroids, especially from a threat assessment point of view.
Hey, Daniel, so Tim was talking in the YouTube stream. I don't know if you heard him.
Sorry, I had that muted.
That's fine. Yeah, it's a little confusing right now. We could just have Tim talk in the WebEx if you are in it, but it looks like yeah, you are. Tim, do you want to talk in the WebEx?
Yeah, so I was just commenting that the idea to cluster the asteroids seems like a pretty good one, especially from a threat assessment point of view, in order to, combine a lot of objects. So you don't want to necessarily run through every single asteroid, but you want to get a much more efficient overview of the entire threat picture. So I like that idea a lot.
Yeah, Daniel, great job, you and your team, even if it didn't quite exactly perform as well as you would have hoped. A lot of great progress, really cool to see how you guys came from basically 0 to this over the past couple months. We're really happy to see everyone's progress. So thank you for, joining this, putting in a lot of effort, and showing us what you had. Now we're going to kick it over to look at the final team, Team Asimov. I guess we can ask them, going into this, you've seen what it looks like when the other controllers have performed. What are your thoughts going into this?
What kind of... I suppose I'm curious what you're asking about the other controllers.
How do you feel going up against them? Do you feel confident? Do you feel like the other ones showed a good competition? Do you feel afraid?
I think there's
sports
definitely
reporter in here.
there's something to learn from every controller, I think. I absolutely love the clustering system and the closure rate on the high terries. Definitely, I'm a little bit jealous of that. I mean, I'll be honest. I'm feeling pretty good. I do think that ours will perform quite nicely. But
yeah, I'm in agreement there.
All right.
Yeah, I think ours can speak for itself. I don't want to talk I don't want to hype it up and have it.
We've got big talk from Team 3, Team Asimov. It can speak for itself. So with that being said, let's kick it back to the competition and see what's going to be said. Starting off in the threat assessment, we're seeing that strategy that they talked about in their presentation already panning out. They destroyed all of the small asteroids before they became a problem. And we're seeing some good accuracy. We're not really getting many misses. We're having 150% accuracy, which to some people seeing the stream may seem weird, but it is possible because the bullet has a non-negligible hitbox, so it could theoretically be hitting 2 asteroids in the same time set. A good recognition right here, being proactive with the asteroids. Okay, we turned around to see the stationary one, which was not actually that much of a threat. If we were in a different situation, we might have actually seen that pan out a little bit differently. Okay, good accuracy right here. We're seeing that their leading is pretty good. Not perfect, like they said. They are still getting a few misses on those accuracy tests. We're seeing that they are much more accurate when they're closer, but further away, their leading algorithm isn't necessarily perfect, like they said. Good recognition there, still taking care of one big group before moving on to the rest.
Yeah, we'll have to hear from them afterwards, but I'd be interested to see if that was something that was learned during training to close in order to assist the leading.
Interesting there that we waited until we got closer to get that last little asteroid. Theoretically, if their algorithm was good enough, they could have just shot it from their position further away, but they seem to prefer being close for all of their shots. It makes sense. They have less that they need to lead, less potential for inaccuracy in their calculations. But it does put them in a situation where they could be in a dangerous spot if they get too close. Move that out of the way, sorry. I thought that was an asteroid. Okay, a little less proactive now because this wall has made it a little difficult for them. Things are spreading out more. Maybe we might see that come back to bite them in the butt.
So they did mention that it misses first shots on those accuracy tests because of the turning. So that might be something else that could be improved in the future.
Yeah, so I don't remember exactly how I implemented the environment, but it could be the environment is rendering before they shoot, so they are using last time steps. I don't exactly remember, and I'd have to go back into the code to know for sure, but that could be part of it.
Could be. Yeah, and it'd be interesting to see how maybe adding some intelligence there that could be learned during training could compensate.
Right there. Sorry, Tim. I just want to cut you off because we saw good avoidance behavior in the gap in the wall. Sorry, Tim. Continue what you're saying. I just want to point that out.
I was just saying it might be interesting to see how some training with intelligent systems might compensate for some of those things. But yeah, some great avoidance we're seeing.
Yeah, we're seeing good threat detection where if something is getting closer, we are processing that and taking care of it before it hits us. We are not seeing that aggressive of an avoidance maneuver. It's just kind of a slight back away or acknowledgement, but not a full-on back up, back up, back up with exclamation points. Okay, the ring closing situation. Let's see how they can do in a near-apocalyptic scenario. They're backing into the danger zone, and this is where they respawn too, so they have to stay out of there. Wow, that did not work out well for them. They're a little confused right now. Not sure where to go. Interesting to see that there.
It looks like the hospital situation, though, did work on the last one, somewhat.
The only hospital situation I saw in that scenario was them going to the hospital.
Oof.
Okay, pretty good. We do have a lot of asteroids floating around. Let's see if this causes some problems later on. We are doing a pretty good job doing narrow misses. We are mostly avoiding these asteroids, which is good to see. So, do know with this, I think I have this set so it's a 60-second time limit, so we may not see all of these asteroids be destroyed. We may see this cut off at 60. Yep, we did. When we did the full evaluation that you'll see in the data that we give you, those were run over 100 seconds, so I think likely that scenario did finish, but we're not seeing it here. We just wanted to keep this, short and sweet and not have these scenarios go on too long. Don't want to take too much time away from your Saturday. But yeah, we're starting to see a true asteroid field right now. This feels like this could be in a movie right here. Looks like he is Neo in the Matrix, dodging slow bullets left and right.
Yeah, I'd be curious to see what Harry Stamper thought of this.
Oh, that was a fast avoidance. That was really interesting. We haven't seen that much from them. Or maybe it wasn't an avoidance and it was some other maneuver that worked as an avoidance. Interesting. Some of the behavior that we saw in the wall scenarios were very proactive, but with these ring scenarios, you miss that shot because your leading system isn't perfect. It hits another asteroid, which adds to the field. So being proactive only works if you hit every shot. See, some of those strays are accidentally getting the other asteroids that we didn't want to get.
Also important to note that all hits are considered equal on the large and small asteroids currently.
Mm-hmm. So right now we're still seeing greater than 100 accuracy, so they are still getting some double hits. Right here, with how they're recognizing asteroids, there were a little bit of overlap, and they missed their intended one because it was behind a big asteroid, opening them up to more asteroids blowing up. So maybe it's worth it to calculate that in the future, but I know with the information we gave you in the controller in that environment, we did not give you the hitbox for the asteroid in all that data because it would slow everything down so much. But it's something to think about. If a size 1 and a size 4 asteroid are really close to each other, maybe don't shoot. Because you do have the size information, and you do have all the other state information, so you can work your way around that without the hitbox. Okay, let's see how the wrapping happens. We create a good corridor where we can operate within. Starting getting that danger zone, but we open that back up. Didn't take care of those asteroids that were shooting away, I presume because they weren't a threat, because they were going away from them. Threat detection is still not perfectly proactive with eliminating smaller asteroids. We did snap between big and small asteroids, which created, more asteroids in the field.
I'd be curious to hear from the team if they considered total number of asteroids, and that led to prioritization of certain asteroids. In the beginning, that was a really interesting situation where it was being backed up by the wrapping wall and was able to shoot its way out.
Yeah. Not sure if it's intentional recognition from understanding the wrap, or once the wrap happens, then they instantly become a threat and you have to maneuver that way. It would be interesting to ask the team if they proactively considered, the wrap before it happens as opposed to after it happens. So we do see some really good behavior all in all from this. They said during their presentation that they trained over a large number of asteroids, so their system actually got designed around these types of situations where there were a ton of asteroids around. So that might have also had an impact on their final product. If they had only trained over smaller scenarios, they might not have, adapted to these new scenarios as well, because they only, they would have only trained over such a small portion of a potential solution space.
Yeah, and one instance that we saw in this scenario was a small wrapping asteroid that just caught it near the edge. And they did mention the edge clearing, so I was curious how that handled that.
So I also point out, I remember you guys were bragging about your print statement explainability. If you can see in my console right here, you guys did have a lot of print statements saying that something's wrong in one of your calculations. Thought that was pretty important to point out. I think in Hey Terry's, they also had a print statement that I think there was a divide by zero error in their fuzzy C-means calls once or twice. Okay, we're seeing some interesting jiggling in and out of different dodges and firing states. And yeah, this is going to end before they are able to clear all the asteroids. But we do have data about the full scenarios that we'll be giving you guys in the form of a website where you can look to see how your scenario performed over, or how your controller performed over time over all of the different scenarios. And we'll be dropping the link in the WebEx and probably emailing it and probably even putting on the YouTube comments. I don't know, we'll figure that out.
This wrap situation had a very interesting thing happen where it looked like when they were in hospital mode, or whatever they called it, they actually tried to fly to a region away from a lot of asteroids during that respawn time.
So Nick has a question that maybe we will address in the Q&A with the team after this. They're curious if your AI takes into consideration the invincibility time during respawn when you are slightly transparent, like right here. Because it could be a good opportunity while you're invincible to put yourself into a better position, especially if you spawn right on top of asteroids, like the ring closing scenario that we saw earlier. So we're seeing some really good results, and I do want to re-emphasize one of the great points that this team made during their presentation, and it's something that we really like to say ourselves, is that if you can solve a problem, just solve it, and then use fuzzy logic elsewhere. Because for the leading of the bullets to the asteroid, that's something we've all learned, how to calculate velocity and project where an object is going. So when and where you can, solve the problem and use fuzzy logic for more of those strategic scenarios, things that you're trying to solve from a humanistic perspective.
Yeah, maybe in the future they can incorporate that when they have sensor noise.
Mm-hmm. Yeah, that's one thing to think about. What would you guys do? And this is not Team Asimov, this is all three of you. How would you handle sensor noise? How would you handle firing inaccuracy? I guess that kind of goes with, sensor noise to an extent, but it's not on the sensor side, it's more like on the control side. What if we had a limited number of bullets? What if you were sharing the field, the asteroid field, with another team? Would that change what you do? Awesome. So we just saw Team Asimov and their controller. They said it would speak for itself, but now let's ask them if it did speak for itself, or if we need to get more information from them. What else would they like to add? So I'm opening this back up into the WebEx. Hey, if you are on the WebEx from Team Asimov, what are your thoughts?
I think we're all here.
Yeah.
Okay, so.
So the accuracy, it was working where it was actually entirely perfect. We merged it with there's still misses in some edge cases where the asteroid goes off the screen. And when we merged it with the fuzzy system, and no fault of the fuzzy system, just something with how the code was working with each other, it stopped working all the time. And so you got those cases where while it was turning, it would shoot and miss. And then that's what some of the hesitation was that it was showing. And I went, well, we worked for a while to fix it, and I was just like, no, it's fine. It's most of the time. Mm-hmm. But it was really disappointing to see it miss.
Lister told me it would kill him on the inside if it wasn't perfect. I'm sorry, buddy.
But yeah, I'm still really happy with how it turned out.
There was an interesting thing where with the problem in the left-right checker, I think I know exactly what went wrong. That print statement happens specifically in cases where it can't decide whether or not to turn left or right, which is why it was just sitting there straight upright shooting at one point. And I think the reason why that happened is because the left-right checker has a bit in place for when it respawns, so when it's sitting at the absolute center. And I think that respawning it in different places was what was making it jib out like that.
Oh, like it respawned in the center instead of its current location?
No, I mean like you at the beginning of the scenarios, it was just kind of sitting up, pointed up at the screen, shooting. Like it would until asteroids got close to it, it would start until something like made it evade out of its respawned position. It was just sitting there shooting directly upward on the screen.
I see.
Yeah, which I'm pretty sure is we made some kind of mistake in dealing with the left right how left right plays with the respawning. Yeah, I'm really happy with the performance.
Yeah, it's good to see what you guys were able to do within the time period too.
Yeah,
we're really happy with it.
I saw you guys had a few questions.
Forward, what would you guys consider doing differently? What do you think, aside from little error here, little error there? What would be a big sweeping change that you would make?
Do the GA early.
Yeah. I agree with that. Big one. I like having this philosophy to train early and to train often, even just to check to see if there are any errors in your system, because we found in many ways, shapes, and forms that GAs are great at finding errors in your code and the code of the environment that you're working within.
Yeah, we had some kind of error that was crashing our GA, which was unfortunate. That killed a lot of promising chromosomes.
Yeah, we don't know really what was going on, but we were getting similar errors, Wesley and I at least. I don't know if Lester ever did, but it would go through a number of generations and then just freeze up for some reason.
Yeah.
Yeah, the GI I ran didn't really have that. I don't know why you guys had that issue, but mine did. And that's
I think you guys asked the question of whether or not the search and destroy was learned behavior.
Yeah.
Getting closer. Kind of. Lester, do you like to explain it? I know you mentioned that in your slide there.
Sure. I mean, initially when we first made it, it had no way of, we didn't have the anticipatory aiming at all. So it would never hit, it would just do that thing where it scrolls by the side of the screen and then never hit it. And so just a very early fix was, we thought, okay, well, I think it was, you initially had it set, Wesley, as after a certain amount of time, it goes and does that. And I figured, why don't we just, set it so it immediately does it and just see how that, works out. And it turned out it actually was really good because it would get in close and then, it would be able to clean up asteroids very efficiently, which you saw there a few times.
Yeah.
It definitely has its downsides, but I think having that, even on the 20 asteroid runs that we were doing a lot of the time, it was still beneficial.
There's another advantage of getting close besides just accuracy that I noticed. One thing I noticed was that it also helps with time to kill. Where basically what happens is when it gets close like that, it can pick a target, it can shoot at it, and then it can move on to the next one in a lot faster of a loop.
Yeah.
Where when it's and that's a reason why you wouldn't necessarily want to just plink at them from far away, because it would pick one target and then we have an adjustable fire rate. Unfortunately, Lester had dreams of having it based on the full number of asteroids on the screen, but we just ran out of time.
I'll also interject about what you're saying about being closer time to kill. That's important, and we saw this in some of the ring scenarios where if you were trying to shoot an asteroid and it was overlapping with another asteroid, then you'd be shooting that bigger asteroid potentially. So if you're shooting at something further away, that may overlap with another asteroid that you're not intending to hit. So just being closer gets you to take care of that specific asteroid that you wanted to get and potentially less likely to get another one that you didn't intend to get.
Yeah, exactly. Yeah, especially with video games like this, there's just a lot of unexpected behaviors that can pop up. Like, we hadn't even considered the interpose problem until we actually started playing with the ROE. And the genetic algorithm actually favored a smaller radius of engagement than because we expected it to want a big one, that it would want to be able to shoot things from across the screen, but the GA told us no, it doesn't like that.
I don't hope that in that case we're training on 17 or 20 asteroids, which generally then if you miss it all, you're creating a whole new region.
Our baseline training situation was 15 to 17 asteroids.
Okay.
And then we'd put it on 20 if we really wanted to see how much sauce it had.
Yeah, and I really liked what you guys were saying about the way that you adjusted your training was that you had a lot of lives, and then you tried to maximize the amount of lives you had left rather than training to time, because you can get some really interesting and not really good behaviors if you train with time being an important part of your GA, whereas the GA may prefer to stay alive longer and maybe you would shoot less. So just making sure you pick your GA fitness function in a good way that if you were to think about it thoroughly, it will give you the exact behavior you want. I think you guys did a great job with picking that.
Yeah, there is one disadvantage to picking based on lives, and that's that if your ship is having trouble surviving scenarios, then it becomes very limited how much you can learn from each one. We definitely, because we didn't start genetically training until we'd already hard coded one that could beat 3 asteroids.
So I'm going to take the link to the data. I'm going to drop it in the chat. Oh, it looks like Tim Arnett did that already. He put that into the chat for the WebEx. I'm going to put it in the YouTube live stream, and maybe I'll also put it in the Slack as well.
Yeah.
So this data is something that we put together that shows the performance of you guys compared to each other over each scenario in a summary table, and then also has each individual scenario where you can look at everything by the time step. So you can see how you performed over time compared to the other teams. So you have access to this. We train this over a larger portfolio than what you guys saw during the competition. About twice as large. We took some scenarios out just because, like the accuracy tests, there were sometimes, things wouldn't get hit and it would just take a while.
Yeah, the accuracy on ours looks really low. I'm looking at the website right now.
Oh, partially because our rate of fire was turned up so high.
Yeah, that's probably.
If we had a lower, whack track, it'd be.
We called our rate of value coefficient whack.
Okay. It depends on the scenario. but maybe that summary table we might have to relook at. But if you look on a scenario by scenario basis, you can see
Sure.
the accuracy like time right there. So
Oh, I see. That's cool.
that-
I loved. I was dreading that corridor test. I know we never got a chance to do that one, but
yeah,
that one.
That's
that
maybe a next year thing. The other teams, their stuff slowed down a lot, and we just didn't want to wait a lot.
I think the simplest way to beat that corridor situation for next year's teams would probably be to focus on to have their threat assessment rate stagnant asteroids as not much of a threat.
And also, you'd have to know if there's going to be an asteroid in the way of a shot. That was the really important one, I think.
Interpose, yeah.
Okay, cool. So I guess this is for the event coordinators. How do you guys want to wrap this up? So Javier, Lynn, Tim, I'm going to open up to you. I'm keeping this stream running so we can, keep their comments in the video. Just curious what you guys want to do from here.
I think it's fine to move back over to WebEx.
Okay. Do you need me to cut the stream off right now?
Yeah, let's go ahead and cut the stream off.
Okay. Well, cool. Say bye, everybody.